This last example wants us to do everything algebraically first and then check it graphically. So again, algebraically, how do we find an inverse of one equation? We're going to switch the x and y values and solve for y. So if I want to find the inverse of y equals 3x minus 6, I would switch the x and y values, solve for y, so I'll add 6 to both sides, then divide by 3. And I want to check, does that equation match with the other one that they gave us? No. So these ones are not inverses. The second one, we just make a little note here. The second one is a parabola, been flipped down and moved up 3, and they've given us a restriction on the domain. So we are looking at only half of a parabola here, not the whole parabola. Our question is, when we look at that half of the parabola, does it match up with that equation? So as far as solving this one algebraically, to begin with, we would start with our equation, which is negative x squared plus 3. We would switch our x and y values. So then instead of y, we write x. Instead of x, we'd write y. And solve. So x minus 3 equals negative y squared. Before we can square root, we would like to get that y all by itself. So to get rid of the negative, we can either divide by a negative 1 or multiply by a negative 1. If I multiply the left side by a negative 1, I get negative x plus 3 equals y squared. And now I can square root both sides, and I get plus or minus negative x plus 3 equals y. Now, since we only had half of the parabola to begin with, because there was a restriction on the domain, we know that we're only going to have half of this answer. We have to find out, are we going to have the positive part, or are we going to have the negative part? Now, the restriction on the domain was that x was bigger than or equal to 0. So when x and y get switched, that means for our inverse, switch the x and y has to be bigger than or equal to 0. So which half do we have? The positive or the negative? If it has to be bigger than or equal to 0, then the one that we have has to be the positive one. Does that match with the other equation?
Yes.
Yeah. How did they write it? They wrote it like this. Are those the same? Yes, they are. So we can say yes, these are inverses. In part 2, they say verify your results graphically. So if I graph the first one, the two different lines, the one line was 3x minus 6. That has a y-intercept at minus 6, a slope of 3, rise of 3, run of 1, rise of 3, run of 1. That's the graph of y equals 3x minus 6. For the second graph, they have x minus 6 all divided by 3. One of the things in this course and other math courses, you've got to be able to manipulate things to get it into a form that you're able to graph with. This is a line as well. Can you see that I could rewrite this by dividing each thing by 3? I could have 1/3 of x, and then -6 divided by 3 being -2. And that puts it in y equals mx plus b form. I now have a y-intercept of -2, up 1 over 3, up 1 over 3. And this is the graph. How can I tell graphically that those aren't inverses? If you draw the diagonal line, so we draw the diagonal line, y equals x. What's wrong? It's not. Okay. If it was flipped over, this point should be the same on both, right? And it's not. Or this point should be the same on both, and it's not. Another thing you could do graphically is you could take a point. Here's 0, -6. Where should that be if you switch x and y? It should be at -6, 0. Instead, on our other graph, we have 6, 0. So we can see from the graph that these aren't inverses. For the parabola, we have -x² plus 3, but only when x is bigger than 0. There's our vertex, and we only have this part of the parabola. We want to check if the square root of 3 minus x, and I'm going to write it as -x plus 3, because that matches more with how we work from left to right. What's the minus going to do? Flip it over the y, and the plus 3. Move it over to the left, unless we notice that, there's our special note again, we have to have it in factored form, so we'd have to take one extra step, especially when there's just a negative. That's going to be the easiest time to forget that you have to factor that out. So we flip it over, move it 3 to the right, not 3 to the left. Now when we do a quick check, does it look like it's been reflected over this line? Yes. It seems like that point matches up. We had the point 0, 3. Now we have the point 3, 0. So graphically, this one matches up. Seven, 8, 11, and 13. I have a note that says 11 and 13 are a little bit different. They're going to make you think, so make sure you look at those ones and figure them out, or come in for extra help.